Another Leetcode problem today, 2685. Count the number of complete components. Let's first try to understand what is a complete component. Let's just use this example. Maybe it's easier to explain. So what is the formula for a complete component for a graph? So for example, the first one, we have one node with one edge. So for the second one, we have three nodes and three edges. And for the last one, we have two nodes and one edge. So there must be some relationship between the number of nodes and the number of edges. Let me use n as the number of edges, number of nodes, and e as the number of edges. So what is the mathematical formula for it? If you know about the mathematical formula, then you can solve the problem. So n is the number of nodes. So the formula is n times n, let me check, n plus 1, n minus 1. It should be n minus 1. N minus 1. So this is the formula. So for example, if we have this formula is so if we have one node, what's gonna happen? So 1 minus 1, it is 0. So I think it should be n plus 1. If n equals to 2, it's gonna be 3. If n equals to 3, the result would be 3. You see, if n equals to 3, the result is 3. If n equals to 4, the result should be 6, n times n minus 1. So what if n equals to 2? N equals to 2, the result is 1. If n equals to 2, 2 times 1 divided by 2, it is 1. What if n equals to 1? If n equals to 1, the result is 0 because there's no edge. This is 0. Here I did something wrong. There's no edge for only one node. So this is the formula. If you know about it, so the number of edges, this e, should be equal to n times n minus 1 divided by 2. If you know about this, it's going to be easy to solve the problem. Now let's just start coding. And then you need to know how to check the number of edges and how to check the number of nodes. Basically, it's going to be inside of the DFS. So let's just start coding for this problem. So let's just start for UV in edges. Let me prepare an adjacency list. So it should be default text and it is a list. So GU should append V, and this GV should append U. So this is the adjacency list. Now we can start the DFS. So for the DFS, I'm gonna starting from a node I, and I will give a pass. Now let's go to the main function. So for the main function, we have we have a number of n nodes. So this is given. So we're gonna check one by one. So the nodes gonna be starting from 0. So the nodes is starting from 0 to n minus 1. So for I in range n, we're gonna check if it is invisited or not. So if I not invisited, so this means we're gonna prepare a visited set, and I also need to prepare a result. So the result would be starting from 0, and the visited set would be just an empty set. If this I is not inside, what I gonna do? So the visited set should add this I, and I can execute the DFS with I. And what about the result? Would plus equal to something? Let me just give a 0. I will change it later. Finally, I'm gonna return this result. So this result, as I said, it's gonna be some formulas. So let me prepare the formula. I will use self.e as my address and self.n as the number of nodes. So it would be a formula. So the result would like plus equal to 1 or plus equal to 0. It depended on the number of edges and the number of nodes. for each of the component. Yeah. So I'm gonna use the self.e as the number of ads. So if the number of ads equal to self.n times self.n, yeah, self.n plus 1 and divided by 2. So if it is like that, it's gonna be like plus 1. If it is not, it's gonna be plus 0. So I don't need the parentheses. I think it is still okay, because it's gonna execute the multiplication first and then the division. Yeah. Now I'm going to calculate this adds and this not. Yeah, this is gonna be easy. Let me just finish the DFS part. So for neighbor in GI, if neighbor not in visited set, what I'm gonna do? So visited set would be add this neighbor, and I will execute the DFS with neighbor. Yeah. Now, how can I count the number of ads? So, yeah. So this means I needed to do some preparations. Yeah. So before the DFS, I needed to prepare a self.e and self.n. It should be starting from 0 and 0. Now, for this component, I'm gonna execute the DFS. After DFS, I'm gonna calculate this self.e and n, and then I'm gonna put it inside of the result. I'm gonna check if it is equal or not. If it is equal, I'm gonna plus a 1. Otherwise, I'm gonna plus a 0. Yeah. Now, how to calculate the adds? So for calculating the adds, it is just before above the if tag. Yeah, because this neighbor is just all the adds connected with this I. So if it is I, so all the neighbors, for example, that be connected. Yeah. So self.e should plus equal to 1. Yeah. So this is calling the number of adds, but there is duplicate, as you see, like 0, 1, 1, 0, 1, 2, 2, 1, 0, 2, 2, 0. So it means there is a duplicate. This result should be divided by 2. Yeah. I will divide it by 2 later. But let me just count the number of nodes. For this component, so self.n should plus equal to 1, because after the visited set tag, if it is not inside, so this n would always be the number of nodes. Yeah. Now it means this e should be divided by 2. Yeah. So if this is divided by 2, and this side should also delete the divided by 2. Yeah. So if I delete it, it should be okay. So this is the entire code for the function. Now let me just have a quick check if there's something wrong with it. So this is the graph, this is the DFS, and this is my result check. Yeah, let me just run it to check. It seems okay, as you can see. Now let me submit it to check if it can pass for all the testing cases. Now as you can see, it passed all the testing cases and it's pretty fast. Thank you for watching. See you next time.